Welcome to my fifth Blender 4.91 tutorial. This tutorial will cover the Blender BPY modules, aliases, types, and a function for creating a moon or an asteroid. If you put in dir BPY, what you will get is right here. And everything you see in pink you're probably not ever going to use, and I'm not going to go over it. You'll see it in the notebook, and you can go over it if you want to, but I'm going to skip it because probably not going to use it. Things that you will use will be bpy.context. It contains settings like the current 3D mode, which objects are selected, and so on. These are all the items you'll find under that. BPY data, access to BPY, Python, internal data contained in the current blend file for objects, meshes, materials, basically anything you find in the file. BPY ops provides Python access to calling operators, including operators written in C, Python, or macros. And BPY.types, information about the types of objects. And I'm not listing them because it's very huge. If you want to list it, you can go dir bpy.types and you'll be able to see it. And now we have math utils that I'm going to go over. So you have color, Euler, quaternion, vector, BVH tree, geometry, interpolate, KD tree, and noise. Some of these you probably will not use unless you get into some like deeper technical, but so for a color, it's going to come out like this. In fact, if you wanted to like create a color, you could go color equals, and the settings for color are usually 0 to 255. It's going to be RGB, meaning red, green, blue. That is how color is controlled. It also covers the conversion from HSV colors, has no alpha channel. Euler is used for controlling X, Y, Z axes. The bad part about Euler is it can be prone to gimbal lock, but that's only if you're animating, like you're not using code, because I've never experienced gimbal lock using code with Euler. So you can safely use Euler in your code. As far as I know, I've never had any problems with gimbal lock using code. Matrix is any kind of linear transformation. And this has a default matrix, but you could go, let's see, matrix equals. And so the default is the identity matrix with a 4x4 matrix. Quaternion, that's another way of rotating. It's a lot cleaner. No gimbal lock. Vector, you'll run into vector a lot. It's really just like X, Y, Z coordinates. BVH tree structures are for proximity searches and raycasts on geometry. I've never used it. Math utils, geometry. I don't think I've ever used that one either. Okay, and this math utils interpolate only has one. Like if you go back here and you hit tab, you're only going to get one thing in the whole thing. And that I haven't used before. Same way with KD tree, and I believe it does the same thing kind of as math utils does. You only get one thing. It's for performing spatial searches, find points within a radius of a 3D cursor. Math noise, you probably run into this before if you've done texturing. It's basically for adding noise to your textures, things of that nature. You can even use noise in your code. Now say we want to list the objects in our scene. This is a way to do it, and you could also go L equals list of objects. Then it lists what objects are in the scene. It's a good way to reference them. So say if I wanted to reference moon, reference it. Let's try it the other way too. I think there's a different way of doing that. I don't think this will work. Yeah, I was right. Okay. And then because it aired out, it didn't do anything for him, I don't think. Right. Okay, so. And then also for bpy.context, you can use a capital C. And with bpy.data, capital D. So instead of writing this out, you can just put capital C and then whatever after it that you need to do. So C dot, and then if you hit tab, you can see all the things that you can do in context. Same way with data. You can create your own aliases. For example, if I wanted to create a vector, I can go vector1 equals mathutils dot vector. Vector1, and it's at the origin. And this is how you'd actually get moon by the name BPY. So you could go, instead of typing that out, you could put D and it'll get moon. And then we'll get moon location. Let's change the moon location. Let's see, BPY context mode. Alright, yep, I'm in object mode. And the reason why you'd use that is, say, if you wanted to find out what context you were in during your coding. Alright, if we set x equal to 40 and then we go type of x, it's going to say int or integer. But if we set x equal to 40.0 and then we run that type x, we get float. So how you initialize a variable can determine what it actually turns into. Type Boolean. And then type tuple. So if you want to set it as a vector, you've got to go Then I want to show you a short example of building a class. A class is kind of like a cookbook. You don't use the class itself. It's not part of the ingredients, but it holds the keys to making something awesome. So when you want to use the class, you would not type in point.x. Let me run this. So if you typed in point.x, you get nothing. So what you'd want to do is you'd want to go maybe p equals and then point with parentheses at the end of it. And then if you wanted to get point x coordinate, it prints out the point for x. If you wanted to change that, you would go p.x equals 4. and see it's changed. And this is a really small example of a class, so you might not see the real benefit of it, but you can create big classes. Like, say, if you're creating a character for a game or something, you want all the characteristics of the character readily available. You could create a class called character, and then you could have like all of the different attributes for the character. And then after you created that, you could maybe go C equals character. And then whenever you wanted to reference anything to do with the character, you just go C dot, like maybe height. And you'd have it. It makes it really easy for programming with classes. Let's see here. Where next? Oh, okay, so moon. I changed this function that we were using earlier. I renamed it to set pivot and made it so that we could actually just run it. It'll actually work on whatever object is active, and you can set the pivot point to any place you want rather than just 0. Also, the object by name function that I created earlier, I made it so that you could decide whether you want to deselect everything else or whether you want to leave something selected and select something else. And the reason why I wanted to do that is because if you're doing booleans, you got to have 2 things selected at a time. So, and you'll see that in this function. And then I have a small function here separated out to create the actual sphere for the moon, and radius setting that is located here, and it's located down here in this function. This function is the part that creates the craters. Crater count, x starts out at 0, and crater count is however many craters you want to create. By using modulus, I'm able to control whether I'm creating large craters or whether I'm creating small craters. So every time the modulus, the way modulus works, by the way, is, say, x equals 8. And then I want to test x on a modulus of, let's say 4. It'll give me 0. So if x is counting up to, like, say, x equals 1, and then you do a modulus on x of 4, you'll get a remainder of 1. If x equals 2 while you're counting up, and you do a modulus of 4 on it, you get 2. And then so on. As x equals 4, it then goes to 0. And when x equals 5, it goes back to 1, which is great because then you can control the frequency of how often something is occurring. If you want to experiment with that code to actually see it, what it's doing, you could probably put in print statements like print x, print modulus x, something like that. You could go print x, comma, and then x modulus for whatever you want to try. I'm working off a 9, so you'd probably go 9 just to see what it's doing. And this right here sets the depth of the crater, and we're adding a smaller sphere, and we're locating it so it's just a little bit more than the moon's radius, and rotating it once, naming it crater, and setting the pivot point. And we set the pivot point to 0 because there's nothing in here. It's automatically 0 if you don't add anything to it. And then we're using modulus again to change the location where the Boolean is going to occur. And then we're using random range to create a angle for the small sphere to rotate around the big sphere. And then what we're doing is we're using the select function to select object by name. We're selecting moon, but we're leaving the sphere still selected. What happens is the sphere goes around and around this thing and stops somewhere based on the randomness of it. And then it's intersecting with this big sphere. And then what we do is we select moon and we leave the little sphere selected so we can do the Boolean on it. Then we do the Boolean, which is these 4. And then object by name crater, it selects crater again, which is the small sphere. That's what I called it. It's not really a crater, but it's what forms a crater. And then after we've selected it and only it, not the moon with it, by using true, then we delete it out, and then we increment x so it comes back up here and starts doing the loop again. I'm going to show you now what it does when it's processed. You're going to notice there's going to be a delay because it's going to take a little while to actually process it. And then down here what I've got is create equals true. It's going to assume that no moon exists at this point, and then it's going to check all the objects and see if moon exists. If the moon already exists, then it's going to do nothing. So that first run we did, it came across here, it stayed true because no moon existed. And so it went ahead and created the moon. But now if I press this button again, it won't create another moon. All it'll do is create craters. So we press it again. And add a bunch of other craters to it. So you can just keep adding craters to your heart's desire. And I discovered that this was a little bit more difficult to deal with than I expected as far as getting it to look right. So I'm going to show you how I did it. Also, if you select this, you probably want to deselect it before you rerun this, because I don't think it's going to work if you do it that way. So anyway, just briefly to show you what I did to get this to look right, was I went into decimate for modifier, went up 1, and then applied it, and then I came back here and I subdivided it again, and then it looks pretty good. I suppose if somebody wanted to, they could pull the edges out a little bit more, but there's a way to do that too. You could select the sphere and shrink the sphere a little bit. Looks like that one didn't work out very well, but as a general rule, you won't see them too much. Most of them will work out pretty good. And so that code's in the notebook, and thank you for watching the tutorial.